Okay, let's look at this question. A particle having charge and mass, it's connected to a string. Let's look at this string. Okay, you can see this Q is connected by this string, and it is connected from this P point. Okay, the particle string and P point all lie on the friction horizontal table. The particle is released from rest. It is quite important. So my initial velocity is 0. It means my kinetic energy at initial state is 0. Okay, nice. And the angle is 60 degree. There is an electrical field. Determine the speed of particle when the string is parallel to electrical fields. Okay, it means when this particle come here, of course, this string is parallel to electrical field, isn't it? Can you see? Electrical field is going here, and my string is on here, so they are parallel each other. Perfect. So it is asking again the speed. How can I calculate the speed? We can use energy transformation. So if we use total energy and total energy is conserved, we can calculate easily. Just you can look at this word: kinetic energy plus potential energy at initial state, kinetic energy and potential energy at final step are equal each other. But initial kinetic energy is 0, I know, because the speed is 0 at initial state. How can I write this part? Of course, if you put this one to here and take the kinetic energy at final state to the other side, finally, of course, this side will be, sorry, final minus initial state for potential energy. If I know this one, I can calculate this part. I can calculate the velocity. Firstly, I have to know potential energy difference. What's the potential energy difference? I know potential energy equal Q delta V. I mean, charge multiply potential energy. Sorry, potential difference. Yes. How can I calculate the potential difference? I know potential energy difference equal minus electrical field dot product ds. What's the dot product? Dot product give always cosinus information. Okay. I have to know the angle between electrical field and ds. I want to change my color to show my ds. Okay. I need to calculate the ds. I need to see ds information. Ds is coming here. And if I move this electrical field here, of course, electrical field is going on positive x coordinate system. So your electrical field is here. What is the angle between ds and electrical field? Say theta phi. Okay. So how can I calculate this one? If this is theta and maybe how can I show it? Give me a second. I want to show much clearer way. To show better way, I try to understand what's the angle here, angle between electrical field and ds. Maybe we can produce a triangle with perpendicular angle. So if this is theta 90, so this one is 90 minus theta. Nice. And here I will change my color. Okay, so here This is total one is 90, but this part is 90. I know, because total one is 90 degree. So if this is part is 90, again, this total angle is 90. So here, the angle between electrical field and ds is 90 minus theta, isn't it? Can you see? I hope you can see. I hope it is clear. Why I need to I need to find the angle, because we have to use cos theta, cos alpha. Maybe I can say alpha because of this cross product. Okay, so because of this cross product, it will give cos and angle between electrical fields and the ds, which is 90 minus theta. Okay, and then be careful. What's the ds? Even I can show there is a ds here. Oops, sorry. I will, maybe I can clean and I can show better way, with better way. Okay. So the displacement is, come on. Okay. The displacement is this one, isn't it? Can you see? So what is the ds? Can I say instead of ds, ds equal L d theta. Bakın arkadaşlar, şuradaki dikkat et. Çok özür dilerim. Şurada yay gibi geliyor, değil mi? Onun için bu yayı, d'si nasıl yani yazacağız? Hani birimsel olarak yazmak yerine zaten açı değişiyor. Dikkat ederseniz hep integralde şunu düşünün. Ne değişiyor? Açı değişir, değil mi? Bu aşağı indikçe açı değişecek. Biraz daha aşağı indi. Ne dediğimiz şey oradaki açı. Onu alsak, yani açı cinsinden düşünsek olur mu? Olur. Okay, instead of continue with English. Instead of ds, can I write this one? Yes, you can write it, this part. So finally, your integral returned this part. This one is coming from ds, perfect. This one is coming dot product and electrical field. I have to define my limitation on integral. What is my first angle? My first angle particle is here, so my first angle is 60, and then at final position the angle will be 0, isn't it? Can you see? Because we try to calculate now, we try to calculate the angle, changing angle at p point. So now I think we can write it. Oops, sorry. So just we will we will write the my limitation on integral. What is the cos 90 minus theta? This part is coming from, sorry guys, my pen doesn't work. Yes, okay. This part is equal to sin theta. Just this is math information. It is not about physics. This one is this information coming from mathematician. Okay. So, and then my way is easy. Just I will take the integral for sin theta. Sin theta gives cos theta. Just I will put the limitation 0, cos theta 0, and then first angle cos 60, and then we calculate the delta V. Just we will put this information here. This is delta V. Q delta U equal Q delta V. I know. If you put all information, finally we can calculate the velocity. Just put that all information. Your velocity is 0.3 uh, meter over second. Okay, look at this question. Calculate the electrical potential at point P on the axis of annulus shown in a figure which has a uniform charge density sigma. Okay, how can I write sigma? Instead of sigma, I can write for total charge, I can write Q over. It says charge density. What's the sigma? We can say the surface. Sigma gives surface charge density. Or even we can write this one instead of this one, sigma equal dq over dA. Okay, I wrote that information here. How can I calculate the potential now? I know potential is, sorry, my pen again doesn't work. So, sorry. How can I calculate the potential? If I just take the sum ring like this. Oops, sorry, my drawing is really bad. Anyway, even I can take from here. Just assume we have like the ring. Did you remember? Maybe I can show from the previous section. I will show the other question. Where is it? Okay, give me a second. Yes. We try to imitate this part. Okay. We already solved this question. I will try to imitate this one. Okay, now how can I calculate the potential? Of course, normally I know potential equal K Q over R. I know this is my potential. What's the R? If I take from here, I have to know this displacement. This displacement. So if this is X, and if this part is its radius, they are. So this one is equal r square plus x square root of. Okay, square root of. So can I write this part to here? Of course, I will take very tiny ring, charge ring. So I take just small part. It means dv equal k dq. So this part has dq charge, very small charge. Okay, and we just write its distance. Okay, which is this part. Nice. Instead of dq, can I use this information? dq equal sigma dA. What is the dA? I know surface equal P r square. Oops, sorry, I wrote it wrong. Okay. How can I take derivative of these two parts? Of course, pi 2r and don't forget that dr. We will still need to use this part one. So instead of dA, you will write this one. Instead of dq, you can use this form. So I know this one is coming from dA. Okay. So now just we will put all information here. We can make organization. How can I take the integral of this part? Did you remember we need to change some parameter? Or I can write here instead of r square plus x square. Can I write a? Yes, you can write it. And we can change this derivative. I will take derivative of these two parts, okay? So it means you take derivative of a, and here 2r dr. This is constant. This part is x square is constant, so it will give 0. So you can write 2r dr equal dA. Look at that part. Can I use, I will change my color. Okay. So here, look at here. Can I use this one and this one equal to dA? Yes, you can use it. So I can write again pi sigma k, okay, dA over A. Because we say this part is equal A. This one is much easier to solve. I need some space. Give my space, give some space. Okay. So continue. Can I write here P sigma K and A over minus 1 plus 2 dA. Just how can you take the integral of it? Of course, you need to add 1 plus and you need to divide by with this number. And then your result return A 1 plus 2 over 1 plus 2. So now I can write A equal R square plus X square. Just I will write this that part and then I will put limitation. Pi sigma K over, okay. Just I will put A and limitation. So it will come to A over, sorry, maybe I can put here, not A, sorry. R square plus X square, and we need to put its limitation. One of them is A, the other one is B. Why I take the A? Because it is asking the potential for this material. This material start from here to here. So firstly, I will take this part and this part. So I have to I have to span from here to here. My first limitation is A. The second one is B. Okay, because charge on here, so I will try to show from starting from first point to second point. First point reduce is A, and second point final point reduce is B. Okay, if you put that information to R square, of course your result return this one. Please put this information B square plus X square, and don't forget to write sorry, here there is 1 over 2. It means there is a square root. Maybe I can write this like this. Okay, here it is much better. There is a root, square root. Okay. So when you put that information, of course, it will return X square plus B square minus square root X square plus A square. I hope you understand this part. We can move other question, last question.